Hello world, it's Rational Pi, and I'm back here today with our MBA conferences project. We're going to go ahead and try out this new layout where I have my Visio spreadsheet over here, and then I have my code over here, and then hopefully you can read both at the same time. That way I can reference one and the other. So we're going to basically build upon what we did last time, and we're going to start out the same exact way, where our MBA conferences is going to create a city and path structure, and then we're going to obtain city information from the user. So that's not going to change, so we're going to go ahead and skip down to that part. The only thing that has changed in that section is that we've added some do-while loops. And what these do-while loops do is it reads the structure or the data type of what the user inputs. And if it's not what we ask it for, then it's going to ask the user again to input the information. And we'll test that out here in a little bit. But for example, for longitude, if the user doesn't put in a double, it's going to ask the question again. Technically you could throw an int in there, but that's going to be fine because ints can be referenced as doubles. But if they put a string in there, it's going to ask them again. And then, so that's the only difference between the city information now and the city information before, is that we finally fixed that. We went ahead and caught that error. Now, the thing that is different is we're going to automatically generate the path information. So what we did was, instead of asking the user input the first node, input the second node, and then it's going to find the path between those nodes, we just went ahead and automated that and assumed that the user wants all of the path information between all of the nodes. And obviously that's not going to be the same when we eventually do our A* method, but for now and for our initial analysis, for another couple videos probably, this is going to be fine. So it's going to do the same exact thing as what our multi-dimensional array did, and it's just going to keep filing through all the information, and then it's going to assign the first latitude, first longitude, and second latitude and second longitude, use the Pythagorean theorem, and come up with a path cost between the two cities. And then what we're going to do is, instead of using that multi-dimensional array, we're going to utilize what's called a data table. Now, a data table is very much like an Excel spreadsheet. You have rows and you have columns, and in our instance we're going to want 5 columns. We're going to want the starting city, first node, ending city, second node, and path cost, as you can also see here. And what we did was we created a data table called MBA data, and then you say it's equal to a new data table, and then it's just going to be empty data table because we're going to input everything ourselves manually. So then you say MBA table.columns.add starting city, type of string, first node, type of int, ending city, type of string, second node, type of int, path cost, type of double. And so what that's going to do is going to create an empty data table with the 5 columns. Now we need to input information into those columns. Now this is what's going to replace that multi-dimensional array loop that we created in the last video. So, but it's just going to utilize the same exact structure. And instead of entering it now into a multi-dimensional array, it's just going to automatically put that into our data table. So we're going to say data row, which is like a new row, and it's going to say new path is equal to MBA data.new row. That's about as redundant as you can possibly get, but that's how you create a new row. And then we say if the node that we have is equal to the first node, then the starting city is going to equal to the node that we're looking at. The first node is equal to the node that we're looking at, and then it's going to search for that other node that we don't have, and then it's going to take the city and node from that and put it into our new path, and then it's going to put the cost into that path. Same thing over here, just the node that we're looking at now is the second node. It searches for the first node that we're using when we found the path, and it's going to create a line there. And then at the very end, once we have all 5 pieces of information, no matter what node we're looking at, either the first node or the second node, we're going to say MBA data.rows.add and the new path. So that's going to add the row to the data table. So what this effectively does, it takes all of the paths and it creates a line in our Excel spreadsheet for every single path. That includes all of the information for all the nodes, all the names of the cities, and the path costs. And it's going to be very helpful later whenever we want to export that to a Excel file or in a CSV files for manipulation of the data. So once that's done, once we have our data table set up, we're going to go ahead and sort some of it. We're going to create a new data view, which is like manipulating the data table to a point where it's satisfactory to what we're wanting to look at, and we're wanting to sort the path cost. So we're going to create a new data view, and it's going to be our default view, and we're going to sort it via the path cost right here. Sort path cost right here. And then we're going to call a new data table NBA data sorted, and we're going to assign that data view to a new table. So we're going to have the NBA data table and then the NBA data sorted table. The only difference being the NBA data sorted table is sorted by the path cost. So now we're going to print all of the information that we have. So for each row in the data table sorted, we're going to create a new path as kind of like an indicator when one path ends and another path begins. And then for every item in our item array, and for, just so you know, there's going to be 5 items: starting city, first node, ending city, second node, and path cost. And then we're going to have that print counter that's going to tell us which one we're going to print out so that we can identify what the information is that we're looking at. So if it's 0, or if the print counter starts at 0, it's going to say starting city, and then if it's 1, it's first node, 2, ending city, so on and so forth. And then that's how we're going to print our information, just to make sure everything looks right. And then this read line is kind of like a pause, and that's going to be the end of our program. So let's go ahead and do a 5-city test. We're going to put it right here in the middle. So enter number of cities, 5. Enter the name of city of node 1, Oklahoma City. And we'll just do it by 0s and 5s and 10s and whatnot. Enter longitude 0, 0, 0, 0. Oh. So here's, and you can put anything for the names of the cities. Like I could name it 0 if I wanted to, but let's go ahead and call this one Dallas. Now I wanted to show, if you entered like a D here for longitude, it's going to ask him again because that's obviously not a double. So then we'll start with this one with 5, 5, 5. Then we'll do Denver, 10, 10, 10. Let's do San Antonio, 15, 15, 15, 165. And then we'll do Atlanta, 20, 20, 20. So, okay, here's all the path information, with all the highest path cost being here at the bottom, and the shortest path cost being up here at the top. So it's going to say starting city is Oklahoma City, which is node 1. The ending city is Dallas, which is node 2, and the cost between those two cities is this. And it's going to do that for all of those paths. There's going to be 4 paths for every city, so there's going to be 20 cities to, or 20 paths total, and it's going to sort them all. And a lot of them are going to be the same since we used intervals of 5. But the highest one is going to be from Atlanta to Oklahoma City, which does make the most sense. And it's going to be 28.28. Now, just as a reminder, these values are not in like miles or kilometers. They're in degrees of longitude, latitude. So I'm going to have to get a conversion that is appropriate to link between degrees of longitude, latitude, and miles or kilometers, however you want to look at it. And then also, I obviously did not use the appropriate longitude and latitude values for each of these cities. So that's another thing we're going to have to look up. But that's kind of what we're looking at. This is how you use data tables. They're very, very helpful, especially if you want to export data and then import data back into the code. They're very, very helpful in that manner. That's what we're going to be doing in our next video, is we're going to translate this information to a CSV file, and then we're going to manipulate that CSV file to find the top 4 cities for every city in the NBA that's closest to them. There's obviously going to be a little bit of overlap, like cities with Oklahoma City that have a lot of cities around them. There's probably going to be quite a bit of overlap with at least with that 4th city. And we'll go ahead and see how that looks next time, and then we'll start building our A-star method. If you have any suggestions or concerns or questions, please comment below. You can always reach me on Facebook or Twitter. You can also message me on here if you'd like. A like and subscribe is always appreciated, and I'll see you guys in the next video.